Good evening, everyone, and welcome. It is my great honor to welcome you to the 2021 Priestley celebration. Each year for the past 68 years, we have gathered to present this award to a distinguished scientist in memory of Joseph Priestley, the discoverer of oxygen and a close friend of Dickinson's founder, Dr. Benjamin Rush. The presentation of this award demonstrates the college's strong commitment to the advancement of sciences as an integral and central focus of our liberal arts curriculum, a commitment demonstrated through our vibrant and innovative faculty and our state-of-the-art science facilities. It should come as no surprise that Dr. Rush actively sought out other revolutionary thinkers of his time, including Joseph Priestley. Priestley, who was born near Leeds, England in 1733, had prepared for a career in the ministry, but developed a deep and active fascination with science. In pursuing this interest, Priestley turned to investigations of what he termed different types of air, explorations that led to the discovery of 9 gases, including sulfur dioxide, ammonia, carbon monoxide, carbon dioxide, and a gas later named oxygen. Priestley's increasingly unorthodox views on theology, coupled with his outspoken opposition to the English slave trade and his support of the American and French revolutions, ultimately forced him to flee England for America in 1794. He was already well known for his scientific accomplishments, so it was only a matter of time before Priestley would form a close friendship with the new nation's foremost physician, Dr. Benjamin Rush. Although Priestley died only 10 years after arriving in America, his connection to Dickinson College continued when we acquired much of Priestley's equipment. You can see this equipment, including a large burning glass, an air gun, and a reflecting telescope in our archives. 68 distinguished scientists, including 16 Nobel laureates, have received this prestigious award. The list of early Priestley awards includes Harold Urey, Linus Pauling, recipient of a Nobel in Chemistry and the Nobel Peace Prize, nuclear physicist Edward Teller, and climatologist Morris Ewing. More recent honorees include Timothy Gowers, Fields Medal recipient, Vinton Cerf, a computer scientist who contributed to the creation of the internet, Joan Stites, a molecular biochemist known for her foundational work on aspects of RNA and her advocacy for women in science, and our most recent recipient, Jo Hendelsman, a renowned microbiologist known for her commitment to advancing women and minorities in the sciences. Now, to introduce our newest recipient of the Joseph Priestley Award, I'm so pleased to introduce Robin Okinawa. Robin is a senior environmental studies and philosophy double major. She came to Dickinson because of our commitment to sustainability. And throughout her time, Robin has combined her longstanding commitment to sustainability with her drive for social justice. Her co-curricular activities on campus, as you might expect, are many, and they include the Black Student Union, Divest Dickinson, Hypnotic Dance Team. She's a peer advisor in the Career Center and a member of the Liberty Caps. She has spent her time at Dickinson fine-tuning her personal passions of environmental justice to hopefully one day pursue a career in activism and policy. In her time at Dickinson, she's enjoyed connecting sustainability to social justice through academics, service, and her personal endeavors. Robin, would you please introduce our honoree?
Absolutely. Thank you so much, President Ensign. Good evening, everyone. When we held Clark Forum events in person on campus, we took a moment to acknowledge that the land on which we gathered belonged to Indigenous peoples for centuries prior to European colonization. Currently, I am inhabiting the ancestral land of the Lenni Lenape, the Susquehannock and Conestoga, the Haudenosaunee, the Shawnee, the Erie, and later the Indian children of the Carlisle Indian Industrial School. I would like to encourage everyone watching this evening's program to take a moment after our presentation to acknowledge the tribes whose traditional land you currently inhabit. Also, following this evening's talk, Clark Forum Student Project Manager Logan Court will be moderating the Q&A session. So without further ado, tonight it is my distinct honor to introduce this year's Joseph Priestley Award winner. I was so excited to be a part of this evening's ceremony because the Joseph Priestley Award is, as President Ensign said, presented to a distinguished scientist whose work has contributed to the welfare of humanity. As I pursue a career in environmental activism, I do believe it is so important to uplift those who are using their specialties to uplift our society and make the world a better place. Tonight, I will be introducing the winner who did just that throughout her career. Dr. Jane Lubchenco, University Distinguished Professor at Oregon State University, is an environmental scientist with expertise in marine ecology, climate change, and interactions between the environment and human well-being. She served under Secretary of Commerce for Oceans and Atmosphere, the administrator of the National Oceanic and Atmospheric Administration, or NOAA, and as an inaugural member of President Barack Obama's science team from 2009 to 2013. She believes in using science and engaging society to craft solutions to society's biggest challenges. She has a history of collaborations with industry, communities, government, civil society, academia, and faith-based organizations to address climate change, reform fisheries, restore coastal habitats, and promote resilient communities. She believes we can harness science and creativity and work with each other and nature to achieve healthy and resilient ocean ecosystems. Dr. Lubchenco received a BA in biology from Colorado College, an MS in zoology from the University of Washington, and a Ph.D. in ecology from Harvard University. Her academic career as a professor began at Harvard in 1975 until 1977 and continued at Oregon State University. She is currently going to take time away from her Oregon State University once more to serve as Deputy Director for Climate and Environment in the White House Office of Science and Technology Policy. Throughout her career, Dr. Lubchenco has published countless papers about her work, but I would like to highlight one in particular, which I believe speaks to her character and why she deserves this award. Published in October of 2020 in Our Moment of Truth, The Social Contract Realized, Dr. Lubchenco writes, "Actions by individuals can take us only so far. To truly help society meet its grand challenges, environmental scientists must now make a quantum leap in engagement with society. It is time for strategic, collective action to change the culture of academia and create the enabling conditions for science to serve society better." This message of unity and community engagement is so important now more than ever as we tackle one of the biggest issues of our time. Luckily, as a student at Dickinson, I've had the chance to practice some of what Dr. Lubchenco has been preaching. In my Environment and Society class with Dr. Beatty, we looked at the social, historical, and cultural causes and impacts of food insecurity. We also got the chance for community engagement with our research as we took surveys and compiled reports to help better understand and hopefully alleviate food insecurity in Enola, PA. As an activist for environmental justice, I couldn't agree more with Dr. Lubchenco. It is so crucial that we all work together to stop climate change, and that can begin right now. Without further ado, President Ensign will now present Dr. Jane Lubchenco with the Joseph Priestley Award.
Thank you, Robin. The Priestley Award, which includes a bronze medallion with the likeness of Dr. Priestley, was first presented in 1952 and has been presented each year since to a distinguished scientist honored for discoveries that contribute to the welfare of humankind. Dr. Lubchenco, I am honored to present to you the Dickinson College Priestley Award in recognition of your extraordinary achievements. And here's the award. You know what? It's not going to show because I have the tulips here. I'm so terribly sorry. But we will get it to you. I would now like to ask Robin to read the citation included with the award.
Dr. Jane Lubchenco is awarded the Priestley Prize for her significant contributions to the field of environmental science and her efforts to understand and protect ocean ecosystems. She is also honored for her dedication to science communication and ensuring science is used in the service of society and the planet.
Congratulations, Dr. Lubchenco, and we are so looking forward to your talk tonight. Thank you for being with us.
Thank you, President Ensign. I'm deeply honored to receive this award and especially delighted to have the opportunity to connect with Robin and to thank her and all of the students at Dickinson and elsewhere who are so passionate about bringing together sustainability and environmental justice. They really do go hand in hand. And the passion that you heard when she spoke is exactly what is needed. So this is a great honor for me. Thank you so much. And it's now my pleasure to share my screen with you and get underway with our lecture. So again, it is just a treat to be here with you. I went to a small liberal arts school, Colorado College, as Robin noted, and I am deeply grateful for that liberal arts education. And every day, it is part of who I am. Yesterday, I had the great opportunity to meet with quite a few of the environmental science and environmental policy students in classes taught by Professors Maggie Douglas, Kristen Strock, and Michael Beavers. And I came away really energized. The topic that I want to focus on today is how we might think about today's challenges so that we have a more just and equitable and healthy and prosperous future. So let's get underway. Since I'm speaking primarily to students today, and since we live in a world of social media and associated acronyms or abbreviations, I want to start with an acronym, bottom line, up front. It's actually borrowed from the military, but whatever. And today I plan to convey the following key messages. Make no mistake, environmental challenges are urgent and they are serious. They threaten our health, prosperity, and well-being. But despite the magnitude of the challenges, it is far from hopeless. Solutions already exist. They're just not at the scale or the pace of change that is needed. Science plays a key role in helping us understand what's happening and what are the likely consequences of different choices we might have. And one key message that is emerging from the science is that the most successful approaches for accelerating the progress at the pace that we need will be through integrated approaches, those that seek solutions to multiple problems simultaneously. I'm going to approach that topic by walking you through these this list of topics. And I want to start with my perspectives to give you a sense of where I'm coming from so that you can understand how I think about these issues and then make your own judgments accordingly. I have been an academic professor for most of my professional career, working in and around oceans, seashores around the world. But I also have had the opportunity to bring some of that science to policymaking, decision-making, and management of natural resource issues. So I think about these issues both through the lens of an academic, but also through the lens of a policymaker, having spent 4 years on President Obama's science team, interacting with national leaders, as a government employee leading a federal agency that was charged with predicting the weather, understanding and tracking climate change, managing fisheries, protecting marine life and ecosystems, and much, much more. I worked closely with the president and members of his cabinet and elected leaders from around the nation, even as shown in the bottom two images, performing chemistry experiments before a congressional committee to demonstrate how ocean acidification works and what its impacts are. Then I had the opportunity to do science diplomacy around the world with colleagues in the State Department. And of course, bringing science to global leaders and listening to them to understand their needs, ideas, perspectives, and carve a path forward. So recognizing that science is important in our lives, I want to emphasize one of the key roles of science, and that is science to inform our understanding and decisions. And I say inform deliberately because science shouldn't dictate what we do. There will be a lot of things that go into people's decisions about what they do personally or what institutions do, but science should be at the table. It should help inform our understanding. A key role of science is also to help co-create solutions, not to tell society what to do, but to work with members of society at all levels, from local to global, to co-create solutions. And I emphasize this because knowledge and information are really the cornerstones, the foundation of a vibrant democracy. And so having scientific information be at the table is critical. Unfortunately, all too often, in my experience, science is not at the table. And it's not at the table because sometimes it's not accessible. Politicians don't read scientific journals. Citizens don't read scientific journals by and large. Or it's not understandable. It's full of a lot of technical jargon. Or its relevance isn't obvious. Its utility isn't obvious. Or it's not seen as being credible. So part of my message is to scientists to help become bilingual, excuse me, and to learn to speak the language, not only of science, but the language of lay people, so that we can share the information that we have and learn from people who are using science and work with them to co-create solutions. So part of this is thinking about what we do with our science, and I think that matters. It's about more than publishing in the peer-reviewed literature, and it's about more than communicating with other scientists, but also with others, with the public, with policymakers, business leaders, young people, civil society. But going beyond that, not just trading information, but engaging with them and understanding their needs, their perspectives, and co-creating knowledge, working together to find solutions. Doing this is a challenge. It takes time and energy, but if we don't value all of those, then we won't be making science as useful to society as it needs to be. Now, we've seen recently challenges to science in this post-truth world. Those challenges are real. And so part of our obligation as scientists is to not just assert that science is important, but to show its relevance, to show that it's relevant, make it personal, show its utility, and help provide hope through tangible, scalable solutions. So I started off talking about my perspectives and my views on the role of science. I want to segue now to focusing on some big global challenges and highlight both some successes and some limitations. I want to highlight these global challenges. They are not all of the global challenges, but they are ones, they're a good starting point. And they cut across a number of topical areas. Each of these grand challenges is a big deal. They affect individually and collectively our health, our prosperity, and our well-being. But before seeing this list makes you too depressed and overwhelmed, I want to note some of the remarkable successes that we have already seen in addressing some of these. And I do so being mindful of the guidance that I received from a Girl Scout leader when, as a young girl growing up, a group of us was hiking up a very steep trail in the Colorado mountains, making for that peak that was our destination, seemingly very, very far ahead. She advised us that looking back, looking downslope to see how far we had come was a useful antidote to the easy discouragement one felt in seeing how far ahead and how steep the path ahead lay. So let's look back together to get some energy and encouragement, as well as some lessons learned. I want to start with air pollution. We have solutions to air pollution. We know how to make progress. And I would note that this is now the 51st year of the implementation of the Clean Air Act, signed in 1970 by Richard Nixon. It has had a remarkable impact in improving air quality across the United States. Now, it's hard to appreciate the magnitude of the transformation unless, like me, you lived in one of the US cities that had horrible air pollution. A single piece of legislation has changed people's lives. To be sure, more work is needed to address pollution that's not covered by this legislation, and more people, especially those who have been historically marginalized, need to be, their pollution needs must be addressed. And of course, many countries have not yet seen this progress. My point here is simply that solutions do exist and are improving people's lives, and we can learn lessons from that. A second and major global success has been the Montreal Protocol, ratified in 1987 by every single country on this earth. That international agreement regulates over 100 people-made chemicals that deplete the ozone layer. This NASA slide depicts the likely difference in ozone concentration in 2065 versus the baseline date of 1974, if the Montreal Protocol had not been implemented. So again, this global success is eminently worthy of celebrating, and it's a remarkable achievement. Now, historically, many of the successes that we have seen could be and were tackled as individual issues. Part of our challenge today is that we are running out of time for issue by issue by issue siloed approaches. And moreover, some complex challenges require more integrated solutions. So these challenges loom large, and they go to the heart of what is needed for a sustainable, equitable, and just future. Let's talk about climate change for a moment. Robin noted the importance of climate change. We know that it affects our health, our food, our water, clean air, exposure to disasters, opportunities for development, and much more. Just to connect the dots on one part of climate change for you, climate-related changes in the ocean affect our weather systems because the ocean is the engine for global weather. Therefore, some climate-related ocean perturbations are affecting the safety, the health, and the well-being of millions of people across the United States. This image shows the record-breaking 22, at least $1 billion weather and climate-related disasters in the continental US for 2020. Now, not all of these are directly connected to climate change, but some most certainly are. And hurricanes are a good example. As a result of climate change, which brings warmer ocean water and warmer air temperatures, we're seeing more of the more powerful hurricanes. In addition, those big, powerful storms move more slowly and last longer over the land, affecting people far inland. And the storms hold more water and so cause greater flooding. The number of hurricanes spawned in the Atlantic and the Caribbean varies from year to year, depending on the water temperature, air temperature, and wind shear in the upper atmosphere. There's also unequivocal evidence that climate change is affecting hurricanes. Now, note, there is no evidence that climate change affects the total number of hurricanes each year, but it does affect the intensity of hurricanes, how fast they move, and how much water they hold. So those climate-related impacts, in turn, affect the intensity of storm surge, coastal and inland flooding, tornadoes spawned by hurricanes, and of course, the destructive impact of more powerful winds. So one of the best examples of the need and opportunity for integrated approaches comes from the ocean. We've talked about some global challenges, some successes and limitations, and I want to focus on integrated solutions and the opportunities for those. And I want to start with the ocean as an example. Now, to think about the ocean, we can understand how some of these topics are connected to one another, and we can see an opportunity for integrated solutions. Let's consider how our thinking about the ocean and our relationship to the ocean has changed through time. So historically, the ocean has been seen as so immense, so bountiful, that for thousands and thousands of years, for most of human history on this planet, we have thought of the ocean as being too big to fail. It was simply impossible for people to imagine that we could possibly deplete it or possibly pollute all of it. That narrative that is still guiding much of the global ocean thinking, much of the globe's thinking about the ocean, is being challenged currently by seeing what is happening in the ocean today. They are depleted, especially of big fish and top predators. They are polluted, they're disrupted. Climate change is resulting in warming and acidifying the ocean. And ocean ecosystems that provide the benefits that we need from the ocean are less resilient and less predictable. So in just a few decades, the ocean has been transformed. And these changes have very real ramifications for people around the world. The 3 billion people that depend on seafood for a significant fraction of the protein that they have every day. People whose jobs depend on the ocean. This impact on the ocean is caused by a variety of factors. There are many drivers. Climate change is one of them for sure, and its corollary, its equally evil twin, ocean acidification. But it's also caused by overfishing and illegal fishing, and the loss of safe havens for wildlife, and pollution. Not only plastic pollution, but nutrient pollution that's running off our coastal areas, and toxins. At the same time, we're seeing this depletion and disruption. We are also seeing more and more demands for the ocean, more need for maritime transportation, more interest in tourism, more demands for seafood from the ocean, both from fisheries and aquaculture, and more needs from the energy, from the ocean for energy or critical minerals. So we need more from the ocean, not less, at the very time that the ocean seems to be stressed. And so many people are sort of pivoting to a new narrative, a current narrative of the ocean that says the ocean is not too big to fail, it's actually too big to fix. There are so many problems from so many different directions, each of which is very, very challenging it's just too messed up. It's just going to be impossible to fix it. And this doom and gloom narrative about the ocean has taken hold. However, this doom and gloom narrative is being challenged by young people, by citizens, by fishing communities, by scientists, and even by government leaders and industry leaders. And I want to share with you some of the ways that this new thinking is evolving, where it's leading to, and what we can learn from that. In many instances, we have scientists who have been working on these issues for some time. And an example that I want to start with is fisheries, because seafood is so important to billions of people around the world, not only for food security, but for livelihoods, for their families. In 2008, scientists, ecologists, and economists published a really interesting analysis of asking the question, do the conditions under which a fishery is managed make a difference in terms of whether it is sustainable or not? And they discovered that fisheries that were managed using the typical kinds of fishery management result in a race to fish, and that in turn almost inevitably results in depleted, overfished fisheries that are on a downward trend, as you see on the red line here. In contrast, fisheries that were managed with some kinds of rights-based management approaches were this purple line. And even though there's a lot of variability from one to another, on balance, they tend to be sustainable through time. The secret here in the difference in the management is to align the short and long-term interests of the fishermen, to align economic and conservation incentives in ways that allow for both success in the short term, but also success in the long term. This scientific analysis led directly to some of the reforms that were adopted by the US government, by NOAA specifically, and by Congress, whose legislation that was passed in 2005, implemented in 2006, triggered some massive changes in how the US regulates federal fisheries in federal waters. And I want to show you some data to underscore how impressive this transformation has been, and suggest the conclusion that fishery reform is possible and it can be highly successful. When we give the ocean a chance to recover, it can, if we are smart about how we do it. So US federal fisheries, and I'm going to compare 2 years, the year 2000 and the year 2018. This is the number of overfished stocks that were reported by NOAA. 92 overfished stocks in the year 2000. And after these reforms were implemented, that was slashed to 41 in the year 2018. So we are turning the corner in ending overfishing in a very impressive direction. Even more encouraging, it is possible to rebuild many stocks that had been depleted and overfished, build them back to a level where they are healthy and thriving and can again be fished. And you can do that. So the year 2000 had 0 rebuilt stocks, 2018 we saw 45. And this can be done in ways that result in increased catches and increase in value. And so there's economic benefit, there's environmental benefit, there is social benefit if the right approaches are used. And so science is informing fishery management. And that, in fact, garnered quite significant attention from other countries, and other countries passing legislation that would adopt many of the same provisions that allowed the successes that we have seen in US federal fisheries. Many governments are paying attention to what each other is doing. And the next example I want to highlight for you is particularly exciting because it comes from the current sitting heads of state and government from 14 different countries. Big nations, small nations, developed nations, developing nations, who have decided that the ocean is key to their future. And they wanted to listen to science, learn from successes and failures, and chart a new course for the ocean. This group is called the High-Level Panel for a Sustainable Ocean Economy, and it got underway in 2018. You see these 14 ocean panel countries on the map here. They collectively represent 30% of the world's coastlines, 30% of the world's exclusive economic zones, those lighter colored bubbles that you see around each of the nations, 20% of the ocean catch globally, and 20% of the world's fishing fleet. So 14 is not a large number of countries, but this particular group of countries are serious players in the ocean space, and they represent different perspectives. These leaders all believe that they need to listen to not only their people, but to science and to pay attention, and they are open to innovation. They are all concerned about climate change. And one of the things that they did was to ask a group of scientists to advise them. I was one of those scientists. And they asked us to pull together reports on 20 different topics to help them understand the state of the science on a variety of issues that they were interested in. And so here are politicians asking for science to tell them, what do we know and what are the options for action? One of the topics that they asked about was, we don't hear much about the role of the ocean in climate change. We know that the ocean plays a key role in the climate cycle. We know that the ocean is seriously impacted by climate change. But what are the opportunities for ocean-based activities to help mitigate climate change? We don't hear much about that. The reason they hadn't heard much about it is that nobody had actually crunched the numbers before. And so my colleagues and I put together a group of the world's experts on this topic, and they produced an analysis. And the report you see in the lower right-hand corner here was entitled "The Ocean as a Solution to Climate Change." This figure depicts the 5 categories for which there are sufficient data available to be able to calculate how much potential emission reductions could we achieve from each of these different buckets: ocean-based renewable energy, wind, but also other renewable energy, ocean-based transportation, so decarbonizing shipping, tapping the blue carbon ecosystems along the coastal areas, the salt marshes, mangroves, seagrass beds that are sucking up carbon like crazy, using fisheries and aquaculture and encouraging people to eat more protein from the sea and less animal protein from land, and carbon storage in the seabed. And so you see in what this is called a waterfall diagram. And you see in this diagram the maximum annual emission reductions that are possible from each of those buckets. And the key message here is that they total to be 21%, or 1/5 of the greenhouse gas emission reductions that are needed to get us to the 1.5 degree Paris Agreement target by 2050. Now that's huge. And it wasn't even on the radar screen. We tend to think about mitigation in terms of terrestrial mitigation. either roads, buildings, energy generation, etc. And here, the ocean is actually offering additional solutions to climate change. So this is one example of one scientific report to the high-level panel for a sustainable ocean economy that has helped driving new thinking about possibilities. The panel brought to its thinking an integrated, holistic approach that was not just about protecting the ocean or producing more from it, but doing so in a way that had three connected overarching goals: to protect the ocean effectively, to produce from it sustainably, whether it's seafood or energy or whatever, but also to prosper equitably. And so here we see the sustainability and social justice connections that are near and dear to Robin's heart. So these three P's, protect effectively, produce sustainably, prosper equitably, really goes to the heart of the ocean panel vision. And on the left, you see the cover of the report they issued at the end of 2020, after 2 years worth of deliberation, where they are setting out a series of ambitious commitments driven by this triple bottom line. Those 74 commitments are too numerous to mention, but this just gives you a flavor for some of these pledges that these 74 commitments that these 14 countries have launched. They are now inviting other countries to join forces with them and to adopt many of the same activities. But they appreciate the extent to which it's not just about governments taking action, but it will in fact need partnerships across science, civil society, industry, government, and intergovernmental bodies to really pursue these integrated solutions. And so they have set in motion these 10 different action groups, each of which cuts across many of those sectors to move along certain topics. The bolded ones are the ones that are up and running. The others are in the process of being formed. So that's an example of global leaders paying attention to science and on the ground successes in their own countries, civil society, youth groups, informing those governments, and those government leaders taking action and inviting others to join them. Another example of integrated solutions that I want to highlight for you is coming from the leaders of seafood companies. CBOS is a new creation. The acronym stands for Seafood Businesses for Ocean Stewardship. It's a really interesting model. It is a partnership between the CEOs of 10 of the largest seafood companies, which you see, whose names you see here, a partnership between those CEOs and scientists led by the Stockholm Resilience Center. And this partnership is providing CEOs with scientific information so that they can understand what it means and what it would take for them to be part of the solution, not part of the problem. How can they actively be ensuring that the ocean is healthy, that climate change is being tackled, so that in fact they can stay in business? It's a very practical endpoint for them. They're also very concerned about social justice issues. And this is a real transformation for many of these companies, and it's a work in progress. There's a lot of work still to be done, but the progress is really encouraging. So here we see new coalitions emerging, new partnerships emerging that are informed by science and that are moving ahead with integrated solutions. Another example that I want to highlight for you is the use of protected areas. In the ocean, these are called marine protected areas. Scientists have studied them for decades, and we have a wealth of information about marine protected areas, especially those that are fully or highly protected from any extractive or destructive activity. Not all MPAs are highly or fully protected, but those that are can bring some impressive results. When you fully protect an area, biodiversity flourishes inside. There's an increase in biomass, density, size, and diversity across all habitats. So MPAs work. They can also enhance resilience to environmental change by protecting the genetic diversity that provides the raw material for adaptation to climate change. Fully protected areas can also restore ecological balance and buffer against mismanagement. But the benefit from fully protected MPAs is not just inside that protected area, but some of that bounty spills over to adjacent areas outside. This is because the big individuals, what the fishermen called boffs, the big old fat female fish, are no longer being harvested, but they are protected, and so they can grow really, really big. And the number of young that is produced scales by the volume of the fish or the invertebrate. And so there is a huge export of larvae that is produced from big individuals inside the protected area to the adjacent areas outside. And sometimes it just gets crowded inside the protected area and fish swim away into outside areas. So marine protected areas that are fully or highly protected have a wealth of benefits to biodiversity. There's no doubt about that. A new paper that was just published this month, I was trying to think if it was still March, this month, suggests that in fact we could be thinking about marine protected areas in a broader way. Instead of just focusing on biodiversity protection, which has been the focus for a long time, they asked the question, what possibilities exist for marine protected areas, fully or highly protected, to also protect not only biodiversity, but recover depleted areas for food provisioning, so to help recover areas outside that are being fished. And thirdly, is there any potential for protected areas to help mitigate climate change? And what they discovered in crunching the numbers was that in fact there are vast stores of carbon on the seafloor. Nobody had actually put the numbers together before, but it turns out there's twice as much carbon on the seafloor as there is, the upper meter of the seafloor, as there is on all terrestrial soils combined. So protecting those stores from being disturbed, for example, by mining or fish trawling operations, can in fact contribute directly to climate mitigation by preventing that carbon from being released into the water column and eventually into the atmosphere. These researchers created this global map of the potential for combining the goals of biodiversity, food, and climate together. And this map shows you where there are places in the world. The blue shows you where existing marine protected areas are. And then the red are areas that would be priorities if you wanted to weight biodiversity protection, food provisioning, and climate storage equally. You could do all three of those, and these are the priority places. So this paper doesn't tell you where to put protected areas. It says, if you want to prioritize these three equally, look at the red places. On the other hand, if you want to prioritize those three goals differently, the methodology is provided to identify the places in the world where that's possible. So we see here across multiple different approaches, multiple issues, biodiversity protection, food provisioning, climate, and other economic and social arenas, that the ocean is garnering increased attention about integrated ocean solutions. And in fact, coming back to our narratives about the ocean, what we are seeing is the emergence of a new narrative for the ocean that says that the ocean is a central component of tackling climate change, food security, biodiversity protection, and equity. It's not too big to fail. We've learned that. It's not too big to fix. But in fact, the ocean is so central to our future, we should be thinking of it as too big to ignore. So these are examples of integrated solutions that allow benefits across multiple areas. And this, I believe, is the way forward. We've been told that we have to choose between the economy and the environment. That is absolutely false. We've been told we have to choose nature or people. That choice is a false one. To benefit people, we need nature. And so these integrated solutions that are nature-based and tap technology, that are local to global, are providing huge energy and huge opportunities that are saying it is possible to tackle many of these global grand challenges and do so in ways that are faster and more effective. So I am hopeful. There's new science that's emerging. There's greater awareness. There's new, bold leadership among young people, among governments, among industries. There's new thinking that is resulting in innovative technologies, non-traditional partnerships, some creative financing, which is really key for making all this work, new fresh champions, new timely institutions and agreement. And there are hundreds of proven or promising solutions. They just aren't at the scale that we need now. But there is hope that we can learn from these and accelerate the kind of progress that's needed. So returning to my opening messages, I would just reiterate to you that the environmental challenges are real and they are critically important, but it's not hopeless. They are solvable if we move quickly. So there is urgency, but there's also hope. And it's that coupled message of urgency and hope and fresh thinking that is needed for us to accelerate the kind of to accelerate the kind of solutions that I think we are needed. So since I'm speaking primarily to you students, I would answer the question that I posed and saying it is possible to use the planet without using it up. We have a lot of ideas on the table, but your energy, your ideas, your creativity, your engagement will be essential. I want to thank some of my students and colleagues, my Ocean Science Innovation team at OSU, and thank the president, thank Robin, thank the organizers of this lecture, and to thank all of you and simply say thank you, and let's join together to make for a better planet. Thank you so much.
Thank you, Dr. Lubchenko. So we'll now open the floor for questions. I'll be taking some from the live chat, and we're still waiting for a few more to come in there, so I'll start off with some of mine. So first off, how do you communicate scientific research in a way that translates well to public policy?
If you've heard politicians talk, one thing that always strikes me is how they like to tell stories. Stories are sticky. People remember them. We like to hear stories about people. And so one good way to share information is to use narratives, use stories that encapsulate the point that you are trying to make. So instead of just barraging people with a bunch of facts and figures, sharing information in fresh and surprising ways can be really useful. In addition to that, one of the key cornerstones of effective communication is know thy audience. And so if you are talking to politicians, you need to know something about who they are and what they know and what they care about, what their history is, who their important constituents are, so that you can help connect the dots to things that are important to them, to things that they are trying to do. That's not only true for politicians, but it certainly is true for them as well. And so telling stories is important. And if I may, I'll tell you 2 quick stories about some of my experiences doing exactly that. When the first one is a boo-boo on my part. So when I was at NOAA, we had NOAA builds and designs and builds and then flies satellites that are key to weather forecasting. And in fact, 99% of the data that go into the numerical weather models come from satellites. So they're really, really key. So the satellites that were up there were doing fine. But the next generation, we were having some real struggles with. And there had been a problem with the satellite program for a long time. When I went to NOAA, I didn't even know that that problem existed. And I was told, okay, now you got to fix this. So we fixed it. It wasn't easy, but we fixed it. And then I went to the Hill to share with members of Congress what we were doing and why it was so important for them to fund this satellite program so that we could have the satellites ready and ready to fly when they were needed. So I went to one member of Congress who was key to funding these satellites and began to tell him about the fixes we had made to the program. And he looked at me and he said, "Doctor, I don't need your satellites. I've got the Weather Channel." And I thought, oops, he doesn't know that the Weather Channel and all the other private weather providers get their information from NOAA. And that information is highly dependent on the information we get from the satellites. And so I didn't know my audience. I didn't know what that individual knew and didn't know. And so then I was faced with the challenge of explaining to him what he needed to know without having him feel stupid and embarrassed that he didn't know it and he should have. So know thy audience is a really key lesson. Do we have time for one more story? Okay. So the second one that I'll tell you is a reflection of the fact that far too many scientists are not as good as they should be at explaining things in lay language. So this goes to my point, excuse me, about the need for scientists to be bilingual. This was 2010. We were in the middle of the Deepwater Horizon oil spill disaster in the Gulf of Mexico. Fishermen in the Gulf were really, really worried about what was happening with the oil spill, because day after day, week after week, the oil was still gushing. There was not progress in killing the well. And President Obama asked Vice President Biden if he would please go to the Gulf, talk to fishermen about what we were doing and what we knew. The VP said, I'm happy to go, but I need somebody who's a more technical expert on what we're doing and how it's playing out. So the vice president's folks asked my folks if I would go with him. So I flew on Air Force 2 with the vice president to the Gulf of Mexico, and on the plane briefed him about what the impacts of oil are on fish, on shellfish, what the government was doing, how it was doing, why it was doing it, because my agency, NOAA, had a key role to play in the response effort. Partway through my briefing of Vice President Biden, he said to me, I thought you were a scientist. And I thought, what's the problem? And he said, I said, I am a scientist. And he said, but I just understood everything you told me. And I thought, whoa, what a condemnation that is of the endless number of scientists that have undoubtedly briefed him over the years. He has this idea that he can't understand scientists. And then when he finds one he can understand, he was full of questions. And so we had a great exchange. He asked lots and lots of questions. I answered the ones that I could. And I was so impressed with his ability to take that information and synthesize it, and then share it, not in a nerdy science way, but a very empathetic way with the fishing communities with whom we met, and to talk about what we knew and what we didn't know, not as a scientist would, but as someone who understood part of what they were going through. And so both of those stories really underscore the importance of effective communication of science and how many opportunities we miss because we aren't prepared or we haven't figured out how to share science in ways that are understandable and relevant and useful and credible. And so scientists that are being trained, scientists that are science majors, pay attention to not only learning the language of science, but the language of lay people.
Thank you. And our next question is, offshore wind turbines are a new priority area for the Biden administration. And from a fisheries perspective, what opportunities and challenges do you envision that as they pursue offshore wind energy?
Mm-hmm. So Logan, I want to emphasize that I am not here as a representative of the federal government or my current position at the Office of Science and Technology Policy. I'm here wearing my hat as an OSU professor. So just want to make that clear. We have known for some time now that the ocean is becoming an increasingly crowded place, and that new opportunities for using the ocean, like wind energy or other forms of renewable energy, or aquaculture, for example, are inevitably causing some conflicts with existing users. Those conflicts are very real, and they need to be approached respecting the multiple types of use we need for the ocean. And so as important as it is to have wind energy, it also is important that we have the processes in place to deconflict areas and to understand the needs of different users.
Thank you. And then our last question for the evening is, in your opinion, can the fishing rights of Indigenous peoples be reconciled with the other priorities you've outlined thus far?
Yeah, absolutely. This is one of the things that really came through from many of the developing countries in particular during the ocean panel deliberations. And there is so much that we can learn from indigenous communities about historic fishing practices and ways to incorporate that into current management practices and policies. And I would point to the successes that we've had with the management of the Papahanaumokuakea, the marine national monument that is in the Northwest Hawaiian Islands. The management of the monument is grounded solidly in Native Hawaiian knowledge and experiences about what sustainable management looks like. And that's an example of incorporation of indigenous knowledge and indigenous approaches and indigenous people in current management structures. And so it can be done in ways that benefit everybody. And I think that's a really great model.
All right, thank you. And just to conclude, we'd like to thank President Ensign, Robin, and especially you, Dr. Lubchenko, for your words this evening. And with that, we'll conclude this evening's event.
Thank you, everyone. It's been a pleasure.